YouTube, this is Bayu here. What I have in my desk is called a sectional aeronautical chart for pilots. Yes, believe it or not, Bayu is a private pilot, a little bit less than 500 hours. But I'm not here to talk about my pilot's ability. I'm here to talk to you about maps. Okay? This is a regular city map, street maps. It's called a street map because you can read the street. That's what it's called, a street map. And if you pay close attention, these gray lines are determine the zip codes. See? Over here, over here, over here, over here, and here in this city is 2, and this city you have a few. So we're not talking about the city map, but any person can read the street. Before I start talking to you about maps, let's talk about quadrants, because it's very important. You have an arrow that goes north and south. North, south. The world is divided by those lines. The north and south line is called latitude. Okay? This is the latitude. You can say the north got an attitude problem, and then you memorize it for life. And the other line is called east and west. This being the east, this being the west. This is called longitude. Okay? This is the basic two lines that you have to know. North and south latitude, east and west longitude. Okay, memorize that. Now, let's go to the quadrant that I was talking about. So you have your north, your south, your east, and your west. Oops, right there. This quadrant is called northeast. This quadrant is called southeast. Northeast, southeast. Let's go to the opposite side. Here is called southwest. Northwest. So, northeast, northwest, southeast, southwest. North, south, east, west. Okay, remember. Okay, very simple. Now, let's talk about this word memory help on mnemonics activity, mnemonics. I want you to, I know I'm a Chevrolet person, so if your Chevrolet get offended, sorry. I got 3 Chevrolets. So, here we go. General, motor. This is for subtract. General, motor, subtract, or subs. Once you remember that you have it for life. General, motor, subs. The opposite will be magnetic to grid you add. Okay, one more time. General, motor, subs, meaning grid to magnetic you subtract. General, motor, subs. Magnetic to grid you add. Now, here is a question. You say, what is a grid? What is a grid? These lines in here are called grids. Okay? This is a grid map. And this is a magnetic, because the red point is always pointing north. My north is that way. See? Okay. So, when you're dealing with a map and a compass, in the military we use protractor. Especially, I want you to take a look at this book. Battery Executive Officers or Platoon Leader Handbook. Cannon Artillery, Fort Rucker, Alabama. Oh, excuse me. That's the aviation school. Fort Sill, Oklahoma. Oops, The redlegs are gonna get upset at me. So this is the basic rule for the platoon sergeant, a smoke, or gunnery sergeant, or the XO. Usually is hiding, never wants to lay the weapons. He's scared of blowing people up, which is true. So this protractor, if you pay close attention, you go from 0 all the way around to 355 degrees. And if you want more accuracy, in the artillery we use mils. Mils. I will spell that for you. M-I-L-L-S. Mil. How many mils are in a circle? 6,400. White right here. 6,400. See, 200, 62, 64, back to the whole circle. Mils. Mils and degree is the same. But mils, you got 6,400, so you're more precise. Talking about artillery, that's why. Now, here in this, my producer said hurry up. No, I'm not going to hurry up because this is mapping. And I have to take it easy. Mapping 101. So now we have this aerial map. Look at, what is this? 96 degree, 97 degree, 98 degree. What do you think is that? Latitude. Latitude. Oh, excuse me. Longitude, because from east to west. Again, 95, 96, 97, 98, 99, 100, 101 degree. And right here, you got 34, 35, 36. That is what you call going north, is your latitude, okay? So, I'm going to put these two helpers right here so you understand that. I'm going to go ahead and circle around, make a circle between 96. We're going east to west, right? East to west. Remember, maps always you read from left to right up. Left to right up. Left to right up. So, if I give you a number, 96, 35. I can give you the longitude 96, latitude 35. So all this black, I'm going to mark it for you. All this black from 35 and 96 go all the way up, 35 all the way up right here, and then come back over here. It comes down. It comes down the other side, but that's okay. You know, you get the idea. So all of these, everything in here is 9635. Okay? This big square. Now that's too big. How are you gonna find this somebody in a huge area? Okay? Again, let's go back to the protractor. Look at the scale. This is 1 over 50,000 meters. 1 over 100,000 meters. 1 over 250,000 meters. Those are the scales. The aviation scales is, do we have it over here? They don't give you that. But I think it's 1 over 25,000. I believe it is. I could be wrong, but I think it is over 25,000. Well, that's the point. So, again, these two lines determine latitude and longitude. But when you put your reading number, you always go left to right. So that will be your 96 first of longitude, and then your 35 latitude north, which will give you a box right here. Now, we're going to take a little break, and then I'm going to give you part 2. Okay? Take a little break. Cameraman, I got to get in my computer. Okay, YouTube, I'm back again. I want you to take a look at this map information. I forgot the technical name, legend, map legend. And I want you to look over here. You got a little star right there. Guess what that is? You got a GN and you got an MN. This is the true north. Okay? True north. Not the magnetic north, but the one that pointed to the North Star. This is the green north. This is the paper north. Paper, because it comes from the Greeks. Now, right here, we have the magnetic north, the one that the compass gave us. And my compass is going crazy right now. I wonder why. Okay, so remember what I told you? From general mode of socks, from grid to magnetic, just subtract. So we're going to throw an asthmas using the grid, the paper, to a magnetic, subtract. So this is what we have. From grid north to magnetic north, we have 5.5 degrees. 5.5 degrees equals 98 meters. Okay? So, whatever line you throw using the protractor, let's say you are here and you want to go to a Sugarberry Park, you line it up right there and you use a rope. You line it up perfect in there. And that will give you 52 degrees. 52 degrees, right? But this is a grid 52 degrees. Grid 52. 52 degrees from right here to Sugarberry Park. So, what is the legend? From grid to magnetic, you're going to subtract. How many degrees you're going to subtract? 5.5. 5.5. Okay? So that would be 5. That would be 12 minus 6, 46. 5 and 5, 10. 6 and 6, 12, 46. 46 degrees. So when you get your compass, you make sure your arrow is on 46.5 degrees. You keep it on 46.5 degrees, and then you walk. You walk from here to here, and you get the place. Now here's the point: how long you have to walk? Okay, then this is when you get a little piece of rope, and then you go from 0 to 1. They give you 1 kilometer. Okay, so let me go ahead and move you a little bit more to the right. So from 0 to maybe almost 2. Okay, we're not gonna be perfect. So from here, you have to be perfect. If I can get it right. This is 1.5, and then that's your half. So 2 kilometers straight line walking. So you have to add and subtract meters because you got to go through downhill right here. Look at it. This is a hill. You see the brown number 650? That's 650 feet. And you see the contour lines are very close together. That's a steep hill. When you see the lines, the contour lines wide open, that means it's not a hill, it's like a slope. Here is flat. See? Well, you see a little hill, but way open. So, basic mapping 101. To close it up, north and south line are called latitude. East and west lines are called longitude. Northeast quadrant, southeast quadrant, southwest quadrant, northwest quadrant. Going back to the big world numbers. So you have 95 degrees longitude west, because we're in the west part of the hemisphere, 96 degree, 97 degree, 98 degree, and then you keep going higher and higher and higher until you get to California, which is what? 200 and so. Yeah, probably 170, 180. And then from the equator going north to the North Pole, you got 34 degrees that it starts on what city is this right here? Armour. That's in South Dallas. See, this is the big airport, class B airport on Fort Worth. This is Dallas over here. So you have 34 degree, 34.30, 35 degree, 35.30, 36 degree, 37 degree, until you go to way up there in the North Pole. And this is the quadrant. This is the quadrant, 96 degree longitude, 35 degree latitude. They give you the whole block, and then you can break it around. Now, remember on the degrees and meals, that's for artillery. That's why artillery people have to be precise when we're shooting. Now you know that I was in the army as an artillery person. I never rode march, I was in the house, and we have to be exactly perfect with numbers because our bullets are 145 pounds and they are for real. They kill people. You see in the wars, everybody gets blown up to pieces. So this is what I have for the map 101. If you have more details, go ahead and write in the remark columns after we post this video. If you want any information for map, and a lot of people request, I can give you more information. The only thing I want you to remember is this formula, because this will determine the azimuth that you're going to be walking or shooting from the grid to a map. This is it. And remember the keyword, General Motors sucks. The opposite, if you have a magnetic and you want to put it on the grid, you add the declination. The declination is the number given you in the scales on the map, okay? And that's all you have to know to navigate using a map. These always face north, the compass will give you the north. Everything else that anybody else tell you, funny baloney. Behave. Talk to you later. Thank you for watching.